Alright, here is the completed capacitor for the filter setup. There's this calls for a 30, a 25, and a 20. No 25s. I used two. These are 22 and 22, and actually I measured them. One is measuring at 22.5. This one is measuring at 24.2, and this one is a 33, and it's measuring close to 34. So they're all within close enough tolerance that they'll do what they need to do. And I've got them gang together with their individual wires coming out here. Again, on this radio, like I said, I have several of these, and they're all different models in that same era between 46 and 48. I think the biggest difference is that the rectifiers and the audio tubes. The 46 uses a 50 L6 for the audio tube, whereas this uses the 35A5. The 48-127 uses also the 30A5, but it uses a dual full wave rectifier tube in there. Quite a bit of difference in the power supply. Alright, I've got the filter capacitor redone and placed back in there, and I'll go over here to my isolation transformer. Yeah, let's see, turn that off, turn down. And we got it on. Let's turn on the transformer. About 70 volts.
Eres mi tesoro, mi motivo de reír a creer y volver a caminar. Y todo te daré de alguna manera. Te quiero corresponder, vivir para ti, para ti. Siempre para mí, de la mano tú me llevarás.
Sound terrible. Alright, I'm just going through all the tubes. I'm on the last tube. I'm on the detector tube. It's a 14B6. My roll chart doesn't have a 14B6. Matter of fact, your typical 7A5s and that type of series, the 14B6 is not in there, but I do have a supplement book that does show those. And the triode, it gives me 2 and 3 to try, tells me the settings, and then I've got the 2 diodes to check, which throw 5 and 6. There's also going to be a short on throws 4 and 7, and to test for a cathode chart, throw 7 and together, 4 and 7 together. So let's run this tube here. And we put pin 1 on filament return on this particular one. 10, and let's see, 14A, B, 6, 10 for the voltage to the filaments, which is 14 volts, or 13 something I think, and then the gain is 11. So see, we've got that set to 10, this was 11, and we have a filament, and we are to do a complete check on each one of these, looking for a short. Oh, short and 4, we're expecting that on number 4. And a short on 7, expecting that. And 8 is the filament return over here. So pins 1 and 8 are for your filament. You're always going to show a short on those. 9's clear, and 10. And so to test this, 2 and 3, thrown and press the test. An extremely good tube. And now to check the diodes, we're going to throw 5. Change this to 35. 5, and then throw. It's also a very good diode. And 6. Same setting, 35. And that's a good diode. And to check for cathode short, 4, and short, then the short light goes out. So good to tube. That's the last tube. All the tubes check out good. So we'll move on to our next. We'll try to get this thing fired up. Alright, we're back and getting prepared to finish the recapping of the last 6 capacitors. But one thing is slowing me up. The electrolytics have been placed inside the old tube here. But one of the things that's concerning me is this 0.2 capacitor right here. Now most of the Philco circuits of this era on these type radios, and including this one in the circuit description in section 3, which is capacitor 302, is a special condenser that has got a wound wire to form a series tuned circuit resident at the intermediate frequency. It's supposed to help improve the response of the IF. And this is probably one of the first era Philcos, even though it says it should have one for this model, it does not. And these are all original parts as far as I can tell. Here's another light chassis that's being worked on with that 0.2 capacitor with the inductor wound on it to create that tuned circuit. And the other identical Philco, the 46, has the exact same thing. So those are real typical, and for some reason this one does not have it, even though it says it should. That chassis looks pretty much unmolested, so I'm not sure what's going on here. And but we're going to go ahead and just replace it, I think, and then see how she responds, and go from there. Okay. And I've got the capacitors ready. Fire up the soldering iron, get it hot, and we'll be right back. Regarding this capacitor here, that is a 0.2. I've got 0.1, so I could put a couple in parallel and still come up with a 0.2. But I've decided I'm going to remove one end and with a soldering gun and desolder it, and then I'm going to use the Echo 950, and I'm going to check that capacitor to see how lossy it is and see where it stands. And if need to, I'll just go ahead and double up a couple, or I may even order a capacitor to take care of that. Let me get the soldering gun out and we'll remove that capacitor on one end, give it a quick test. All right. Paper mica. Wow. How about you? But I believe that's showing. That dead short. Let's see. It's closing up. There's 0 volts. There's 10. It's totally shorted out. Well, I think I may go ahead and just stuff this little guy here. Let's see. I think we've all seen these before. I ain't gonna waste any more time with this, but it was definitely short and dead. But I think I'll put it back in here and go ahead and put a 2.1 parallels in there, and that'll be another restuff. All right, be back in a minute. All right, I've got two 104, which is 0.1s, and what I plan on doing is basically backing these back together, these two together, these two leads together, and they should then, and this will be back to back, should fit in here quite nicely. And we'll just put that back in. I'm not going to worry about the inductor part of this at this time. If seems still a little weak, we might go back and try to put that in there. But I think right now what I'm going to do is finish up and get these to where I need it to go. And let's start with a little bit of shrink tubing. Bend that down and then back this way. and bend this one up. You may want to put some shrink tubing on it too, and up and across, and it should fit right up here behind this one, and give me what I need for his clearance. Alright, let me finish this up off camera. When I get this completed, we'll be right back. Alright, I'm gonna check these here. I have these two here, they're not soldered yet. Have them in parallel. I'll have to take this lead off here. We'll get a phony reading. See, capacitance 200 nanofarads. It's 0.2. Alright, solder these up. Well, let's take this here off. So basically they're just side by side. They're in parallel, and they're both 0.1s, giving a total of 0.2. And these are rated for 630 volts. So we should be able to take a look and turn on a capacitor checker here, the Echo, and let's see where we at. And that looks like right there, close enough to 0.2. Alright, so let's take this over to and check voltage. There's 100 volts, 150 volts, 200 volts, 250, 300, 350, 400, 450, and that's maxed. Actually, I guess that may even be off. It says 500, but I know this thing only shows DC. I think about 430 volts. So, and everything's good. All right. Yeah. DC. All right. We can turn this off. We're done with that. And Okay. I think that's where we need to be with this. And I guess we'll get that placed in there. Continue on.